everybody. Okay, so in this video, we are looking at finding the area between a curve and the x-axis. So we did look at finding the area underneath the curve using integration. Now, what if I'm asked to find the area it makes with the x-axis? So especially when we get to higher order polynomials, say like this one, I will have an area above the x-axis and I'll have an area below the x-axis, right? So it is very important. If I realize I kind of have two shaded areas, two areas between the curve and the x-axis, right? I need to find them separately, and I'll tell you why. We need to find them separately here because my integral above the x-axis will be positive, and my integral below the x-axis will be negative. But remember, we're dealing with area, and we can never have negative area. So we need to calculate them separately because this one will be fine, it's positive, but I'll need to get what this answer is, whatever the negative answer is, and then make that negative answer positive, right, to actually find the total area. So find the area between the curve, x cubed minus 2x squared minus x plus 2, and the x-axis between minus 1 and 2. What I'm looking here, right, the area between minus 1 and 1 is going to be positive because it's above the x-axis. And then the area between 1 and 2 is going to be negative because it's below the x-axis. So I need to calculate these separately. So let me find the integral now between 1 and minus 1. This is going to be x to the power of 4 all over 4 minus 2x cubed all over 3 minus x squared all over 2 plus 2x. Now I find the integral here. So as I said, and then for area 2 is the integral between 2 and 1 of x to the power of 4 over 4 minus 2x cubed all over 3 minus x squared all over 2 plus 2x. Now, like I said, it could just be easy to use my calculator. So I'm just going to open up my calculator here. Right, so let me type my function in here. So let me define my function. So my function now is, let me clear all of this from a previous question. Right, so it is x to the power of 4 all over 4 minus 2x power of 3 all over 3 minus x squared all over 2 and then plus 2x. Stunning. Now I'm evaluating this now between 1 and minus 1. So f of 1 minus f of minus 1. That is going to be equal to 8/3. So my first area is 8/3. My second area will be, I'm now integrating between 1 and 2. So f of 2 minus f of 1. That's going to give me minus 5 over 12. But remember, like I said, right, I can't have negative area. So I just take the absolute value of that, which is 5 over 12. Therefore, the total area will be 8 over 3 plus 5 over 12, which will be equal to 4, 4, 24, 32, 37 over 12. That'll be my final answer there. Plus 5 over 12. Sorry, 37 over 12 units squared. That is the area between the two curves there. So let's have a look at two questions here. So it's an exam style one. So using anti-differentiation, calculate the area between the function. So this is just a function sine of x. So I know the area here will be positive and the area here will be negative. So I'm integrating between 0 and pi. Sine x just goes to minus cosine x. And then area 2 is between pi and 2 pi of minus cosine x. So this will just be equal to minus cosine pi minus negative cosine 0, which is cosine pi, make sure to calculate in radians. Cosine pi is minus 1, so minus negative 1 is just 1. 1 plus then cosine of 0 is 1, so it'll be minus negative 1, which is going to be 2. So this area is going to be 2 up here, and in this negative area, what I'm going to imagine is going to be minus 2. Minus cosine 2 pi minus negative cosine pi, which is going to be equal to, so cosine 2 pi is, there's going to be minus 1, minus, and then this will be 1. The answer here will be minus 2, well, that's going to be positive 2. So the total area will be equal to 4. The area above is 2 and the area below is 2, so the answer is 4. So what would happen is if I just did my integral between 0 and 2 pi, right, that 2 and that minus 2, they end up cancelling out, so I'd actually get an area of 0, right? But we know that's actually not the case. And finally, let's look at this one here. 2011, the curve y equals 12x cubed minus 48x squared plus 36x cross the x-axis at 0, 1, and 3. Calculate the total shaded region enclosed. So I know this will be positive, this will be negative. So I'm going between 0 and 1 of 12x to the power 3 will be 3x to the power 4 minus 48 divided by 3. Did that happen? 16, so minus 16x cubed plus 18x squared. So sub that in, I'm going to get 3 times 1 to the power 4 minus 16 times 1 to the power 3 plus 18 times 1 squared. Subtract in when it's sub in 0, but that'll just go to 0, 0, 0. So it'll be 3 minus 16 plus 18 plus 2. So the answer here will be 5 for the first one. 5 for the first area, and then the second area is going to be between 1 and 3, and that is going to be, now let me just open up the calculator here again. So just define my function. So define my function, going to be 3 x power of 4 minus 16x the power of 3 plus 18x squared. Then I'm evaluating then my function between 3 and then subtract now here 1. So my answer then for this area is negative 32, but again, we can't have negative area, so that becomes positive 32. So the total area then is going to be equal to 5 plus 32, which is equal to 37 units squared. Right. I hope this video was some help to you guys. Next video, we're going to be looking at the area between two curves. Right, I'll catch you guys later. Bye.